Hello, viewers. Welcome again to my page and my channel. That is Chemistry with Mary Esther. I'm here today to educate you on a very important topic that comes out in external examinations. Either WAEC, NECO, JAM. If you check question 1 to question 10, you must see this question always. And the question and the topic has to do with electronic configuration of elements using SPDF. Electronic configuration of elements using SPDF. Now, this is very recurrent. I'm going to handle it shortly in this short video. First of all, what is an element? An element is a substance that cannot be split again into other forms through ordinary simple chemical reaction. In my previous lesson, I've treated the first 20 elements. So that when someone asks you, mention number 10, you can say neon because you already know the first 20 elements. Now the question now is, can you now present the electronic configuration of the elements using SPDF? Now, S should have maximum value of number of electron 2. P should have maximum of 6. These are orbitals. D orbital should have maximum of 10 electrons. F orbital should have maximum of 14 electrons. With this, in each orbital, for instance, this S should have in the bar, it will have spin up and spin down. You see 2 electrons. P should have how many orbitals? 3. Why? So that it can contain up to 6. Spin up, spin down, spin up, spin down, spin up, spin down. 1, 2, 3, 4, 5, 6. With this little idea now, you can know that D orbital should contain how many? 10. And how many orbitals do we have inside D? That is what? 5. F orbital that has 14 electrons, how many should it have? Someone can answer what? 7. Because each of the bars, each of the orbitals will contain 2. Now, that is not exactly what we have for today. But I'm going to teach you a simple trick on how to present the electronic configuration of any element at all using SPDF. Now, follow this simple trick. The first shell 1, should have, is like this, shell 2, shell 3, shell 4, shell 5, 5S, 5P, 5B, 5F, and so on. Let's just be quick about it. Now, I'm going to use arrow to show how you are going to fill in the electrons. This arrow is pointing down. After filling the first one, you fill in like this. Check it out. I'm not trying to corner my hand. I'm using a straight line now. With this, just present it this way, and you'll be able to fill in the electrons. So whenever you are asked to fill in the electronic configuration of any element at all, with this trick, you can write it at the back of your book or anywhere, and you see yourself excelling in it. After filling the 1s, that is first shell bearing the s orbital, you fill the second shell, third shell, and fourth shell, fifth shell, and so on. We're going to try out this with an example. What is the electronic configuration presentation of sodium? You ask yourself, sodium, what is the atomic number of what? Sodium. If you remember the song we sang the other time, you find out that sodium has an atomic number of 11. Let's fill in. So after filling the first one, remember the maximum number of electrons for S is 2. Maximum for P is 6. Maximum for D is 10. Maximum for F is 14. So when you get to a particular level, don't put more than the maximum. Don't put more than the maximum. Now let's go. Now for sodium, the first shell, 1s2, right? 2s2. We have 2 plus 2 is 4. Remaining how many now? Okay, now after 2s, you enter what? 2p. 2p6, which means 2 plus 2, 4. 4 plus 6, 10. How many electrons is remaining? 1, right? Now, after 2p, you go to what? Remember the arrow? From 2p, you go to 3s. Now, 3s, 1. Not 3s2. But because sodium is 11, it is 3s, 1. 2 plus 2 plus 6 plus 1 is equal to what? 11. It's very simple, using SPDF configuration. For instance, write the electronic configuration of neon. You ask yourself, what is the atomic number of neon? The first 20 elements will come back to your head again. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Neon is 10. Atomic number of what? 10. What do? Neon equal to 10. Show the electronic configuration. You try out. 1s2, 2s2, 2p6. 2 plus 2, 4. 4 plus 6, 10. So it is very correct. Remember, this question comes out often. And in an exam, they may not ask you, present the orbitals. How many orbitals will this one have? You should be able to tell immediately. So with this, practice more. Go to the comment section. Bring out some topics that are very difficult for you. And in this channel, my job now is to demystify the abstractness of chemistry and make you to start enjoying it. Thank you so much. See you in my next video.